Let us see one more example on how to solve a differential equation with a discontinuous forcing function. Okay, so here y double prime minus y prime equals to cosine twice t plus u sub 6t. That's the step function, right? So which is, this will make the function is 0 for t is less than 6, and function is cosine 2t minus 12 for t is greater than 6, right? That's what it is. So this is discontinuous forcing function. Y at 0 is -4 and y prime at 0 is 0. So as usual, to solve this differential equation, we need to take the Laplace transform on both sides, right? So that's what we did on the left side, and on the right side, the Laplace transform of cosine twice t is, what is the Laplace transform of cosine at? It is s over s squared plus a squared. You see that? So that is the cosine Laplace transform of cosine twice t is s over s squared plus 4. Now to find out the Laplace transform of the step function here, what is the formula? The formula is uct times f of t minus c. If you have this type of function, then the Laplace transform is e to the negative cs times Laplace transform of ft, right? So here just compare these two, you will get c equals to 6, right? You have f of t minus c. F of t minus 6 is cosine 2 times t minus 6. So f of t is cosine t, right? You replace t by t plus 6 will give you f of t, and cosine twice t. So the Laplace transform of ft will be s over s squared plus 4. So what do you get? The Laplace transform of the whole thing here is on the left side. So this is s squared Laplace transform of y minus s Laplace transform of y. That's why I collected, and then I took the Laplace transform of y. And then plus this is negative 4 times negative s is positive 4s minus 4, that is minus 4, and that is 0, right? So equals to, that is as it is, and the Laplace transform of u sub 6t cosine 2t minus 6 is basically, I just use that, right? So e to the negative cs, negative 6s times s over s squared plus 4. Okay, so now what I do is I move this to the right side, also factor out s. So s times s minus 1 Laplace transform of y equals to, if you move that to the right, you can factor out 4 from these two terms, right? You can write 4 times s minus 1. If you move that to the right side, you will get negative 4 times s minus 1. You see that? Plus this term is exactly the same, this term is exactly the same. So what I'm going to do next is I will have to take the divide by s times s minus 1. If you divide by s times s minus 1, you cancel out that, right? So you will get s times s minus 1, s times s minus 1, and then s times s minus 1 everywhere, right? You see that? So what you get is you cancel out s minus 1 and s minus 1. So what is left is negative 4 over s. Similarly, cancel out s and s. What is left is 1 over s minus 1, s minus 4. And similarly, you cancel out s and s. You'll get e to the negative 6s over s minus 1 times s squared plus 4. Now we use the partial fraction to find out that, because see here we have 1 over s minus 1 times s squared plus 4. If you take e to the negative 6x right down outside, okay? So what I'm trying to do here is trying to find out the Laplace the partial fraction of this term, okay? 1 over s minus 1 times s squared plus 4. So what do? You'll get a over s minus 1 plus b s plus c over s squared plus 4, because that is the quadratic, right? And when you simplify this, you will get a is 1/5, b is negative 1/5, and c is also negative 1/5. That's what you will get, and then after you plug in, you will get that one. Okay, now if you write that in the simplified form in the partial, after you use the partial fraction, this is what you will get: negative 4 over s. For instead of that, you will write that thing, right? That's what I'm writing here. And then instead of that also, you write down e to the negative 6 as out, and then partial fraction of 1 over that thing will become exactly the same thing there. Now you take the inverse Laplace transform, where the inverse Laplace transform of 1 over s is 1, inverse Laplace transform of inverse Laplace transform of 1 over s minus a is e to the negative at s over s squared plus a squared is cosine at, and if there is e to the negative at times fs, that is, for example, this, when you distribute this, you will get that time that, that time that, that time that, right? So that is for this one. You write in the step function form uat and then f of t minus a. That's what you do. Okay, so and then I find out the Laplace transform of each of the term and plug in here. So this is basically the final answer. Okay, Alright guys, let us see the final example for section 5.6. Okay, here we have solved the initial value problem y double prime plus 3y prime plus 2y equals to gt. Okay, the initial condition is y0 equals 0 and y prime 0 is equals to -2, where gt, that the right hand side, the forcing function, is 2 if t is less than 6, t if t is between 6 and 10, and then 4 if t is greater than 10. You know that we want to use we will have to take the Laplace transform on both sides, right? On the right hand side, this piecewise function, we should be able to write this piecewise function in terms of the unit step function, so that we can use the Laplace transform like of this form. Okay, so for that, what we do first is we write this in terms of the step function. Okay, let's write down gt equals to 2 times u0 6t, that is between t is between 0 and 6, right, plus t times u6 10t plus 4 times u10t. That's what you write, right? And then what is 0 6? It is u0 minus u6, and 610 is u6 minus u10, and 4 u10t is as it is. Now what we do is you distribute that 2u0 minus 2u6, okay, and then plus tu6 minus tu10 plus 4u10. Now what you do after that is you take group the terms. For example, this term and that term will have u6 common, right? So you will get what you get is 2 times u6 minus 2u6 plus tu6, that is t minus 2u6, and similarly you got that. And I wrote for 2 times u0 is basically 1, so I wrote just 2 for that. Okay, so to use Laplace transform uct times f of t minus c, you need to have the same shifting, right? The step function has c shifting c, and the function f must have shifting c to use the Laplace transform, right? So we need to have this one must be f of t minus 6, right? That's what you will need, right? Here you will need f of t minus 10. You see that? F of t minus 6 is t minus 2, that's the t minus 2, and you will find out ft equals t plus 4, because I replaced t by t plus 6, so that 6 and -6 will cancel out, so you will get just ft. So you will get f of t plus 4, and then f of t minus 10 is 4 minus t. If you replace t by t plus 10, you will get ft is -t minus 6. The next thing is we will use this Laplace transform uct f of t minus c equals e to the negative cs times Laplace transform of ft to find out the Laplace transform of the function g. So basically what we'll do is you will find out the Laplace transform of each of these terms. Okay, so the Laplace transform of 2 is 2 over s. Okay, and what is the Laplace transform of u6t times f of t minus 6? So this is u to the negative 6s times the Laplace transform of f, right? What is the f in that case? That's the f. So Laplace transform of t is 1 over s square, and Laplace transform of 4 is 4 over s. Similarly we do for the third term, right? So it is u negative 10s, u to the negative 10s times the Laplace transform of negative t is 1 over s square, negative 1 over s square, and negative 6 over s, but I took that negative sign outside here. Okay, so what we do next is we take the Laplace transform of the whole given equation. Okay, you will get s square ly minus sy0 minus y prime of 0 for y double prime. Similarly for 3y prime, 3s Laplace transform of y minus 3y0 plus 2 Laplace transform of y equals to Laplace transform of gt. Laplace transform of gt is basically that function. Okay, so on the left side what you do is you plug in the value of y0 and y prime 0. So basically this is 0, this is 0, so and take out Laplace transform of y. This has Laplace transform of y, this has Laplace transform of y, and this one has. So I took the Laplace transform of y out. What is left is s squared plus 3s plus 2. You see that? And in the right hand side I just basically copied that. And then you see that one of the term is here is negative 2. Negative 2 times negative is positive 2. If you move that to the right side, you will get negative 2. So all other terms on the right hand side is exactly same as the Laplace transform of gt. Now what you do next is you want to solve for Laplace transform of y first, and then you will have to take the inverse Laplace transform to get that, right? To get the solution. So here this is the we can factor this out, s plus 1 times s plus 2. Now we divide both sides by s plus 1 times s plus 2. You will get 2 over s times s plus 1 times s plus 2, and e to the negative 6s I divide by s plus 1 s plus 2 here. You see that there is s squared times s squared times s plus 1 s plus 2, and then s times s plus 1 s plus 2, right? Similarly you do that. So the next step would be, since this is little longer expression, so I'm skipping that, I'm leaving it for you, okay? Next step will be take the inverse Laplace transform. So what we will get is uyt in the left hand right hand side, in the left hand side, and in the right hand side you find out the Laplace transform of that, okay? What is the Laplace transform of this one? The Laplace transform of this one will look like 1/2 s, 1/2 over s minus 1 over s plus 1 plus 1/2 over s plus 2. That's one for this one, and that one, see? And then for the 1 over s squared term, the Laplace transform will look like negative 3/2 over 3/4, negative 3/4 over s plus 1/2 over s squared plus 1 over s plus 1 minus 1/4 over s plus 2. That's the Laplace transform of these terms look like. Okay, and you can find out the Laplace transform. This will be very easy, and then take the inverse Laplace transform to get the final answer. Okay guys.